Recording pending. All right, we are recording. So there were no questions about Module 2. We're going to jump straight into the Python and Matlab sort of preliminaries help session thing. So let me do a screen share. And I need to share my entire screen because I'm going to be popping back and forth between a presentation and Octave. So yeah, so today we're going to talk a little bit about some remedial MATLAB and Python. This is not intended to be like a full instructional course in how to use it, but it should be good enough to get you actually, I need to switch something real quick. I'm going to stop screen share briefly. This is not meant to be a full, this is how, you should use MATLAB and Python tutorial, but it is meant to, get you going so you can at least get started and then bring intelligent questions about the assignment in particular next week and, know enough to Google, okay, how do I do this particular sort of action? I'm going to need a command prompt for the Python part. Okay, so now I can screen share it again. Close that. Yeah, then I can screen share. Okay, so back to the slides. Okay, so some people watching this may or may not have much MATLAB experience. So some quick remedial tips, especially for those that come from other programming backgrounds but don't know MATLAB. Pretty much the entire thing is array-based. There are technically scalars, but it's meant to be used on matrices. That's where the name comes from. It's not math; it's matrix lab. It is one indexed, which will confuse a lot of programmers. So first element is at index 1, not 0. MATLAB can be kind of pricey. Now, all of you will have access to it through the Rust College Virtual Desktop. But if you don't want to have to VPN every single time or whatever, or Duo authenticate or whatever, Octave is a free alternative. It has both a web interface and a desktop version you can download. I don't have a preference because you're just going to take screenshots of plots to put in your reports. But I don't know if you can upload the files I give you to the web interface, so you might be better off with a standalone one. And I'm going to be using Octave today, not MATLAB. So you should be able to do anything you need to for the assignments in it. So probably for the next part in the first slide, but first thing you need to be able to do is initialize an array, and so there's a couple different ways to do it. One is if I just say x equals empty list, I now have a 0 by 0 matrix for this variable. If I had said x equals 1, 2, 3, now I've got a 1 by 3 matrix. That is x. If I said x equals 1, 2, 3, 2, 3, 4, now I've got a 2 by 3 matrix. So that's the easy part. But if you are a program that's used indexing into things, you also say x equals zeros, and it's probably lowercase. Grammatically, it's ES, but it might be just S in, oops, why did I do that? So 2 by 3. There's no E there. Okay, make sure I type that right in the slides. Yeah, I did, okay. Yeah, so now, that's another quick way to get a 2 by 3 matrix. And then if we go back to the old one, we want to get a particular element, it would be, you use parenthesis notation, not braces. So if I want to get element 1, 1, it's 1. If I want to get element 1, 2, it's 2. Element 2, 1 is also 2. That's not very helpful. Let's go back here and say 5. There you go. Now you can distinguish 1, 2 is the 2, so it's column or row first, then column, whereas 2, 1 is 5 because it's row first, then column. So there's your initialization stuff. Other useful tidbits: concatenation. So if I've got a list 1, 2, 3, and I want to add to it, I can just say x equals, no, that would double it, x equals x4, and now I've got a list 1, 2, 3, 4. So that's useful if you need to grow lists. Slicing, yeah. So let's say I go back to my x equals 1, 2, 3, 5, 6, 4. If I say y equals x at colon 2, that's basically saying for all rows, give me the second element. So I would expect that to be 2, 6, a 2 by 1 matrix. So it's a 2 by 1 matrix containing 2 and 6. So that can be useful if you need to pull out an entire slice of something. Not so much. Probably don't need to do that if I remember in like module 3, but like module 5, that'll be a very useful approach. Reading Matlab files. So let's make sure the path is in the right place. You'll notice it's got a current working directory, which if you've worked with like programs before, command line, you should be used to that. I'm gonna go straight to the place where I keep all my like keys and assignments and stuff. And module 3 is going to give you this clocktime.mat. So if you just say, well, clear, we'll clear your workspace, so all these variables go away. I say load clock time. Now, so that file contained 8 different variables, T1 through T7 and Tref. So now all of those variables have been loaded into your workspace. And so, these are, 10,000 long arrays. So it's not going to show them all there. So that's how you load the data. And I'll show you the Matlab or the Python equivalent of this stuff in the second section of these slides. Plotting. Okay, so all the assignments are going to require plots. So if we just say figure 1. So now I've got a figure. Anytime I want to reference this, I can refer back to figure 1. And so if I want to put something on it, then I need to say plot. So let's plot 1, 2, 3 versus 4, 5, 6. Let's go back to the figure and see. Oh, yeah, here it goes 1 through 3, 4 through 6, and it's centered. So now there's commands to like adjust, the extensive axes and where the tick positions are. I'm not going to go through that all right now. But as long as you've got this figure, chosen, then all your commands will affect that. So if I say like title my plot, then you can see, oh yeah, added the title there. If I say what's the command? X-axis, X-label, X-label. Let's say reference clock. And now it says reference clock down there, and I'm going to add a label here. So I say Y label local clock. It's got a label there. So that's how you generate plots. Now it might be easier, like at first, to do everything one line at a time. But when you submit your assignment, you're going to submit a script file. And so that what I do next? Yeah. So I'm going to have, so to run a script, you just, if the script is called filename.m, you would just type file name. So if I say test, I've got the script in here, test.m, it's going to do something. So let's look at what that does. So this is the commands that are in that script. So it makes, yeah, so here's, I didn't show you this. This 1:10, a command window. So I say x equals 1:10. That implicitly makes an array, a 1 by 10 array of all the values in the range 1 to 10. And I think you can even say something like in increments of 0.5. No, increment goes in the middle. Yeah, there you go. So that's 1 by 19, I guess. I guess it's not inclusive. No, it is inclusive. Just my math was wrong. So yes, there's all the values from 1 to 10, incrementing by 0.5. Anyways, back to test.m. That makes that. And so, like I mentioned, the Matlab is array-based, even the commands. So like a C++ programmer would think that, okay, if I want to get the sign of all the values in that array, I will loop over that array and call sign each of them and do an assignment. You can almost always skip those loops in Matlab. If you just say sign on an array, it will do an element-wise sign operation. So I've got these x's here. So if I say, y equals sign of x, now I get a 19 length array that is sign of each of those values. So that can be very powerful. And then the last step, I just do a plot xy. So this will look a little smoother than it did when I plotted a second ago, because now I've got 20 points as opposed to, or 19 points as opposed to 10 points. So there's that. And hopefully all of you on the CS side and EE side have got to the point where you know how to use a debugger. You aren't just putting, the equivalent of, print statements between every line to see where things are. So MATLAB and Octave do have a debugger built in. So if I go back here, and so I can just run it. If I say, run, and then it runs, and the plot was already open, so it overrode it. But I can also, like you would expect in a debugger, I can put in a breakpoint. So if I hit run, it should stop. Yeah, so it stops when it hits the breakpoint. You can see there's nothing in the workspace yet, so because it cleared it. And then if I step, now it stepped one line. I've got x is 1 through 10. Step another line. Y is the sign of values 1 through 10. I step one more line. Then I get the plot. So, if you're struggling with your assignment, if the output isn't what you think, put in some breakpoints, walk through it and see where, do things by hand if you have to, and figure out where things are going wrong. Yeah, so final tip. No, I imagine most of you haven't started on the Module 3 assignment yet, but I wanted to make sure you guys knew how to do it so you weren't asking all these questions the day before it was due. My solution for Module 3 is around 48 lines, not including comments. So if you're getting much larger than that, you might be overthinking it, or you're not thinking, in an array-based manner. And so, take a step back and think about it again. So before we get into the Python version of this, are there any questions? Nope. Okay. Then we're going to show how to do some of the some MATLAB interop stuff in Python. We're going to be using a couple libraries. If you tried to import these things in your Python and it says it can't find it, there would probably be a tool called pip you can use to install additional packages to Python. If you can't figure that out, then you're probably better off going back to the MATLAB approach where everything's built in. So, make sure I got my working directory set, and then I'll go into my Python shell. Okay, so let's import scipy.io. And so if I say x equals scipy.io.loadmat clock time, what did I do wrong? Load mat. If you've taken my game engine design course, you probably know why my fingers like to type load map. This returns a dictionary. A dictionary in Python is sort of like a map, STL map in C++. And so we can see if we actually hit X here, this is everything that's in there. So these are going to have all the same variables you saw when I loaded it in MATLAB. So there should be an X at a tref. You can see here's a list of you know, all things, although for whatever reason, it's loaded in like one more layer. So the actual list is like tref at 0. And so if you want to get the first element, it's not tref at 1, it's tref at 0 at 1. And so there you go. There's the first timestamp in the reference clock. So plotting, there's a very powerful plotting library in Python called Matlab. And so if we import matplotlib.pyplot as plot, and we say plot.figure, it has created a figure. Now, unlike Python where it pops, or MATLAB where it pops up immediately, this figure isn't going to show up until we actually call plot.show. But let's plot x at tref at 0, which gives us the entire thing. Remember, you know, the 0, 0 would be, oh, sorry, yeah, I was doing my 1 indexing. The first element is 0, 0. The second element is 0, 1. But so let's plot the entire tref against the entire T1 for the first clock in the ensemble. Again, that's going to be at 0. Okay, so now there are some values on the plot which you can't see yet. You know, the reference clock would be on the x-axis and clock 1 will be on the y-axis. If I say plot.show, I'll get a plot. And so those are not the values I would have expected on the y-axis, but I'm not entirely certain what the notation means. I think it's because everything is sort of, I don't know what that means. I feel like it's these values all plus that. So that's like they're being clever, but I don't know why they wouldn't have done something similar over here. But anyways, so there's how you show plot in Python. That should be enough, you know, if you can figure out the rest of the assignment to like capture your plots, to give me everything I need for module 3. So, but this is modal, you know, this is gonna hang, the command prompt's gonna hang until I close this. So there's probably a way to do it non-modally, but I don't know off the top of my head, but you can probably Google that. So some final tips, in case you need to like finagle the data to get in some format you like. You can have lists of lists in Python. I mean, I think that's how that stuff was stored in the dictionary. It was a dictionary of lists, it looked like. If you need to add something to the end of a list, you can use the append command. Since the assignments are designed around MATLAB, you may have to simulate sort of the array type operations as loops in Python, or maybe you don't. Maybe it has nice good wrappers on its array objects to do things element-wise, or a map function that can, you know, apply an operation to every element in a list or something. But my Python solution actually ended up being about 45 lines. So it sounds like it's a little shorter than my MATLAB implementation was. Not necessarily the case in all the assignments, but there you go. Now you should have the information you need to get a good start on Module 3 when we get there. I haven't recorded my version of the Module 3 videos yet, so if you start on that like today, you'll probably get Martin's versions of the videos. You know, hopefully this afternoon I'll record mine, and then you would get my version. So any questions about either the MATLAB version of doing things? Am I going to send out this PowerPoint? Yes, I'll put it on the it's not really part of the module 3, so I will put it on the announcements page. And I also, you know, this recording will get posted to the YouTube channel. So I hope that's good enough to get you started. at least good enough where you can Google stuff you need to do to go further. So are there any other questions about like how to use Matlab, how to use Python, or is there any GUI recommended for Python, like GUI development in Python? If I install Python, it came with a IDE that I cannot remember the name of, but that, so in case you want to support like debugging breakpoints and stuff like that, it does all that. And idle, is that what it's called? I can't remember. There are probably better ones out there. I'm not really like a hardcore Python developer, but if you Google Python IDE, if you aren't a computer science person, you might not be familiar with some of these terms. IDE is the like integrated development environment. That's the keyword you should be Googling for, if you want to find, a good way to develop in Python. But yeah, I mean, if you don't know either of them, I might recommend doing the Matlab version, because that's sort of what the assignments were designed around. And Octave is free, and you have access to Matlab through the Rust College Virtual Desktop. But if you think you want to learn Python because it's going to be more applicable in your workforce life, that is a judgment you are welcome to make. Just realize that it might require a little bit more time investment now. So any other questions about like how to do the stuff in Matlab, in Python, or for those that came late, any questions about assignment 2? Okay, if not, then you are free to go, and I will stop this recording and it'll get posted to Blackboard soon.